Hi, students. I want to start this screencast by going over some of the items that were missed on the quiz, on quiz one. And since I'm doing that, the people who haven't taken it yet, can take it for practice later, but it won't count. Um, so this is the modules page in GeoGebra, in Canvas, and at the bottom is this reference. And here is the document for definitions. I called it TransGeo definitions. I may just change the name to definitions because there'll be other kinds of definitions that we will want to look at. And there are some beginning ones here, diagonal, altitude, all those, but the crucial ones, and just because they're short doesn't mean they're not important. So a transformation is, yes, it's one-to-one. That's one crucial word, but the other crucial word is onto. It's onto the whole plane. It can't be a mapping of the plane onto part of the plane. And I think there's some misunderstanding about what a transformation is. It's a mapping of points. Points in the plane onto points in the plane. So it doesn't, yes, a figure consists of points, so it applies nicely to figures, but it can also apply to like 3 points. You can transform 3 points or any subset of the plane. And it does not have to preserve anything. It just has to be one-to-one. That is, if you have 2 distinct pre-image points, you have to have 2 distinct image points. And every point in the plane has to be the image of some point. That's the only condition. A transformation is a very general kind of thing. An isometry, on the other hand, is a very specific kind of transformation. It's one that preserves distance, and that turns out to be a very stringent condition. We've had 3 examples, and reflection, translation, and rotation. And there is another almost as basic one that we'll talk about. And then the definition of equivalence class, directed line segment, vector. Those are a little difficult, but we can discuss other equivalence classes. Maybe I'll put that on the homework. But these definitions allow us to make a very easy definition of translation. And using this equivalence relation that 2 directed line segments are equivalent if they have the same length and how did I say this? Just a minute. 2 directed line segments are equivalent if and only if they are parallel and have the same length. Yeah, since they're directed. So they have an initial point and an end point. And then translation is A prime is the translation by of A by vector V if A prime equals the vector is equivalent to, not equal, is equivalent to the vector V. And that enables us to have a precise definition of translation, but there are also precise definitions of reflection. And so you can't use words like, well, it's opposite, it's kind of on the other side. That's not good enough. It has to be, if A is not on the line, then A prime is a reflection of A in line L if L is the perpendicular bisector of the segment AA prime. And if A is on line L, then, and that's important, the other part too, if A is on line L, then A prime equals A, then the image does not change. So that's the definition. Now you can say it in different ways. You don't have to use the phrase perpendicular bisector, but you have to have all those elements in there to make a precise definition. I'm not sure how many of you are used to precise definitions. I'll have to ask you that in class. Similarly, there's a definition of rotation. A prime is the rotation of A around point P through a directed angle of d degrees. D is greater than 0 if counterclockwise, less if clockwise. If they're the same distance from P, the center of rotation, and angle A prime is d degrees, the directed angle d degrees, plus or minus. So that's a precise definition of rotation of points. Okay, so that's the story about that. And the next thing that I wanted to do was, so I talked about those things. Excuse me for a minute. Yes, the tools needed for printing and some of the documents that we will be using. I'll go back to modules here. And one of the documents that I was thinking of giving for homework or in class, we may start it in class, has, it'll come up in a second, something like this. Will be easier to draw than to try to do something on the screen. And that will happen sometimes. Even tracing paper sometimes is useful. But it would be useful if you had a way to print and scan. So I'm hoping you all have that. Well, this is kind of a heads up. And for this particular document, it would be good if you downloaded it and printed it so we could work on it. If not in class, then for homework. So just to sort of get that going as something that you'll want to do. And some of these are not so, it looks easy, but it's not so easy. Okay, those two things. Then I wanted to show you a video because we talked about shearing a little bit. And this video has some examples of shearing and also get you back a little bit in the geometric frame of mind. I've gotten topic lists from all but Ben and Tommy so far, and I got to get them by Tuesday. And then I'll try to, so I'm kind of set for I'm just going to do what I was going to do for the next week. But after that, I want to take your topics into account. So if you don't get it into me, you're just not going to have a say, that's all.